Brian? All right. So we're going to go to here. This is what we did not talk about yesterday, but on your quiz on Tuesday, I'm bringing back one of the problems that was on the quiz before. And that's the composition of translations.
Test objectives?
These are quiz objectives.
That's fine, yes. If they look page 2, they're fine, right?
This is not on any page.
Okay. Yeah, on it, right? In the front,
Second.
like after.
All right. So the one from before is going to be the composition of translations. Specifically, a composition of a horizontal and vertical translation. So now, another thing I want us to improve on. When you see these funky little things at the bottom of a T, it is a subscript. It is not up here. So if I have 9, -8, and I want you to rewrite this of some ordered pair XY as a composition of horizontal and vertical translation, then it's going to look something like this, where we've got a capital T and another capital T, and you've got to have that little circle because that's the composition operation. This is on your quiz. You want to get caught up, ladies. Tuesday's quiz. Tuesday's quiz. I have done nothing in the computer. All right. So if I want to do, this is going to be the horizontal. That means I don't want to go up at all. So all I want is the horizontal piece, which is 9. This is the vertical piece, which means I don't want to go left or right, and the vertical is -8. So you all did not do well on this on the first quiz, so it's coming back on this quiz. That's the only thing you have to do for composition of translations. All right. Any questions on that? Stephanie? Well, it's XY, it's P, it's triangle ABC. Yes, you need to put an XY because that's the object of the translation. Yeah, and hopefully I wrote it that way. Yes?
Okay, so when you say find the composition of these translations, that's all you have to do?
That's all you have to do. Okay?
Why do we have to put that circle?
This is a big parenthesis because my T's are big. Those are not parentheses. Those are like less than and greater than signs. They're just weird brackets. And that's what they use, so you want to use what they use. That is what says composition. Yeah, that tells you that you do this first and then that second. You will see this again in Algebra 2. Right. You do in the right one, then the left one. Shh. Second thing you need to know how to do on Tuesday's quiz is you need to be able to reflect a figure over a horizontal or vertical line. Horizontal, which is y equals some number, or vertical line. Those are easy reflections. This will require graph paper. Vertical lines are x equals, horizontal lines are y equals. While we're on the reflecting, you will also have to reflect a figure over an oblique line. You had a whole worksheet on this. Granted, there are only 6 problems. Okay, you had a worksheet on this. Trevor, thank you for raising your hand. No, this is 1 question, 2 questions, 3 questions. There's only 5 questions on this quiz. So you have to reflect over an oblique line. You have to reflect a figure over a horizontal vertical line. You have to do compositions of translations. This is what's on the quiz, Tuesday. Now, I need you to understand notation. So when I say you need to understand notation, I will give you, given a description, of a translation. My expectation is that you write, I'm sorry, it should not be a translation, it should be a reflection. Thank you. Here. We'll put that back in the green folder. Reflection. Given a description of a reflection, remember reflections are capital R's, you write the reflection using notation. Yeah. I may say something like, reflect triangle ABC over line y equals 2x plus 1. There's the description.
Can you show us?
I'm only asking you to write it in using notation. So you're going to use capital R, and you're going to do y equals, that's a subscript, 2x plus 1. And then the object of that reflection should be triangle ABC.
That's it?
But if you can't read this, you don't know what to do when I ask you to actually do it. Okay, this is the reflection line. It is a subscript. This is not a subscript. This is the same size as the R. So there's a 5th one. Let me think what the 5th one is. The triangle ABC. Okay, we've got the composition. We've got reflect. Oh, the other worksheet. The other worksheet said 5. You must be able to write the equation of the reflection line. Of the reflection line. Given pre-image and image coordinates. You had a whole worksheet on this. A29.5. This is A29.5. Now you've gotten all your papers back, so you have those to use. And this other one worksheet, I believe, was A29.
Number 3.
Number 3, yes, was A29. That's it. Just 5 questions. Okay?
So
Yeah, 1 question per topic.
what about Wednesday?
Okay, Wednesdays I will get to at the end. Now this is what we're going to do for the rest of the period. I'm going to go over reflections on the coordinate plane. We're going to do some of those reflections. I think you will actually like this better than last night's homework.
All right, good.
And I believe you have a worksheet for homework. Yes. And then I'm going to spend the rest of the period doing the types of rotations that you had to do on your homework, not on the coordinate plane.
Are we going over the next?
So that's going to be after I get this first piece finished.
Do you need graph papers?
You will need graph paper in a minute.
Yes,
And in fact, I want you to get out your foldables because I want you to put these rules on the foldable. So you should be on You should be on your foldable under rotations. Your homework is A32. Didn't you do A31 last night?
Yeah, that was hard.
All right. Okay, my turn to talk, your turn to be quiet. Rotations in the coordinate plane. This is going to be Tuesday's quiz, Wednesday's quiz. Maybe. I'm doing these quizzes to get you study as we go. Wednesday's quiz will definitely be these 4 things.
What if we had that room on our full rotation?
Then why don't you put it on the back side of that part? Okay? So rotations in the coordinate plane. When you rotate 90 degrees of an ordered pair XY, the coordinates switch.
Oh, yeah.
And you take the opposite, that means opposite of the first.
Rotation. Okay. Didn't we do this yesterday? Rotation?
But I did this hurriedly. And this is what your homework is tonight. So this negative means opposite. So you switch, take the opposite of this first one. That means y becomes x becomes y, and you have to do the opposite. So in other words, I asked you for the rotation of 90 degrees about the origin of the ordered pair to -4. That would be switch them, they're switched, and take the opposite of the first.
Why isn't that a capital R?
Because rotations is lowercase r, reflections is capital R. If we let reflections and rotations be capital R, how are you going to know which one is which?
I don't know.
So that was a very good observation. Rotations are lowercase r. Why do we do what?
Why do you make it the opposite?
Why do we make it opposite and whatever? That was where we were doing these little investigations yesterday. If you think about this slope is 5/3. Right, to get from here to here. The perpendicular slope is going to be -3/5. So, but this is the y's and this is the x's. But that negative could be either way. So that means we're going to have my y value is going to be 3, but my x value is going to be -5 because it's in this quadrant. The negative's not on top but the bottom.
I did it opposite. Yeah, it's 3/5, not 5/3. Yeah, because rise over run.
Rise it over. Okay. So this is 3/5, and then this is what? -5/3.
Oh, so it's just because I was saying, oh, she just switched up.
-5/3.
You see that stuff.
So now I messed up on my switch. No, I did my switching right. No, I didn't. So that means that this should be 5, and this should be -3. Now, on a fraction, the negative either can be in the numerator or it can be in the denominator. And if you notice, am I on the negative side of x or the positive side of x? Am I on the positive y or the negative? Positive. That is why x is this one turns negative and that one doesn't.
Which would be -3.
Pardon?
You know how it's -3/5, so you need that one 5 over -3.
Mm-hmm.
The other one is 5/3, so when you
That was our original point. But Lucas asked why, and that is the why.
That is the
oh, so that the other one
That was to
keep prime.
Yes.
Oh,
All right, when you do 180 degrees, it's the opposite of x, the opposite of y. These negatives mean opposite. I don't want you to think that it's supposed to be negative. It means opposite of whatever it was.
I still don't get up top where it says 90, 0, and -4 equals.
This says rotate 90 degrees about the origin of the ordered pair xy. And when you do that, the coordinates and the new coordinates will be opposite of y, x. So you take these two numbers, you switch them, and you take the opposite of the first.
Oh, so just instead of the, alright, I was just because the, like, additional sign, just like that.
Where's the addition sign?
Right in front of it.
That's a
Well,
that's a positive. I took opposite. It's not an addition, it's a positive sign. Yes.
Is there always going to be 0 in the last one?
Okay, that's one of the things that the book says. If we're rotating about the origin, you may not see this at all. If you only see a number, you know it's the origin. Okay? So anyway, suppose I give you the ordered pair -9, 3. So now if I want to do a rotation 180 degrees, that means we keep them in the order they were in, but we take the opposite of each one.
Oh, you're just rotating whatever number is in the frame.
Yeah, this is the point that's getting rotated, yes.
Oh, that makes so much more sense.
Yes, this is a point. This is the problem, this is the answer.
So they're gonna give you the.
Or they'll give you the graph, which you can find the point.
Wait, Miss Brown, would it be negative 3, 9?
Did I switch them?
I don't know. No.
Well, is x in the, did they get switched? Or is x still x and y still y?
That's not a problem. Alright.
Yes.
There was a number in the blind spot. How would you do it? Like not 180.
There won't be a number, it has to be a letter. It's a point. All right. Shh. I'm talking, I need you quiet. Shh. I'll do an example in a minute. Oh, we'll talk about that in a minute. So now we're doing these are all for positive counterclockwise rotations. On this one, you again switch x and y. But this time, instead of the y turning opposite, the x will be opposite. So if I want to do a rotation of a positive 270 over the origin, and that should be a smaller, this is a subscript again, this is low, of the ordered pair 12, 1. You switch them, and you take the opposite of the y. That is its image. Now, if you do a full circle, what's going to happen? Nothing. The point falls on itself. So now, Lizzie brought up a good point. What if we needed to do a negative rotation? What's the rotation of a negative 90 at the origin of xy? Okay? So let me draw you a picture. All right, so we're going to start here. You ready? Okay. So if I go a negative, if I go a negative 90, do you agree I'm here?
Yeah.
Okay. So what kind of positive rotation do I have to get down to there? 270. So this is another thing you have to know. If you want to rotate a negative 90, it's the same thing as a positive 270 rotation. So on the quiz, I will give you this, and you will give me the blue.
Wait, what? How's that even true, though?
What, I just showed you. Let me do it again.
Oh, yeah, oh.
Black. Okay, the black is going to be my negative 90. I have just, negative means we go down. I rotated down 90 degrees. Agreed? Now, if I were to rotate up, how far do I have to rotate it to get to the black? There's 90, and 90 is 180, and 90 is what? 270. Counterclockwise is, no, I'm saying that a negative 90 is equivalent to a positive 270. Okay, so when you see this, Nathan, you rewrite this as this and follow then this rule. Okay, I want you to only know these 4 rules. But you have to understand a negative 90 is the same thing as a positive 270. And since I did not give you any negative rules, you have to make this transformation, this switch. What if I want to rotate a negative 180? So there's green. Okay, so I want to do a negative 180, which means I swing down 90, 180. I'm here. How many degrees do I have to go in the positive direction? So a negative 180 is the same thing as a positive 180. So that's and again, I probably won't give you that one. But I will give you this next one. If we want to rotate now a negative 270 about the origin,
90.
How'd you all know that without seeing it? It is a 90. So yeah, so now look, let's go back over here. All right, I want to do a negative 270. That is negative, there's 90, there's 180, there's 270. What's my positive rotation? Exactly. So on the quiz, I will give you this. And you will give me what? That. So you've got these 4 on Wednesday. And again, I will give you this, and you'll give me the right. I will give you this, you'll give me the right. I will give you this, you'll give me the, I'll give you this, you'll give me the right. And then
I'll give you the Y.
yes, the ordered pairs. Then you're going to give me these, I'll give you these left ones, you give me these right ones. Then I'm going to ask you to rotate a segment, okay? I'm going to ask you to rotate a segment off the coordinate plane. That was your homework last night. Okay? So you've got one of those also. So let's do an example of what we just did. Wednesdays.
We have 2 questions.
Yes. This is negative 3, 1. So, about a point. Now you read off the coordinate plane. Have your rules in front of you. If I want to rotate 90 degrees, what's the rule?
Which Y?
Switch the Y and the X, and who goes negative? The Y. So I'm going to, now watch, I'm going to switch my Y and my X, and who turns opposite? The 1. That is, oh, I'm going to call that P, because I don't want you to confuse that with the origin. That is P prime. If I want you to do a 180-degree rotation, what's the rule?
Switch the X and Y.
No switches. Opposite. Opposite X, opposite Y. That would be P double prime. So over 3 down 1 is P double prime. That's a 180-degree rotation. And should it form a line? Yes. We've got negative 1, negative 3. That was P prime. That was the 90-degree rotation. If I were to draw those in, there's a 90-degree.
Wait, so basically this is just, you don't use your protractor.
No, you're going to like this homework a lot better. You have to know the rules. You don't know the rules, you won't go anywhere.
So basically it's just not using protractor finding.
No, this is easy.
Yeah, okay.
Okay, so now we want to do the same thing, but 270. What's the rule for 270? Switch. The X is negative. So I'm going to switch them. So 1 and negative 3 switch, but now what do I do to the negative 3 that drives Nathan crazy? Positive 3. What's 360? Same thing. Negative 3, 1.
How do you know when to switch those, right?
Because it's all based on the rule.
Wait, so you're going to give us a plan on a graph if you have to do all those different rows?
No, I'm just doing them all so you can see them.
Wait, will you give us the point on the graph though?
Yes.
Okay.
So now let's rotate
Wait, where'd you even get the point?
right there. I'm using P.
Is it all from?
This is negative 3, 1.
So that's there, and then you just follow.
Right. Right. So now let's do a negative 90. Before you do that, you say, I don't want to do negative, I'm going to do what?
Positive.
Positive. So what is the positive? What is 270? Switch them. So that's going to be 1, negative 3. Take the opposite of which one? Right. If I ask you to rotate a negative 180, no, a negative 270, what are you going to do?
90 degrees.
That's the same thing as a positive 90. How do you do a positive 90? Switch them. X is negative. If you don't know these rules, you are toast. All right, one more and then we're going to go into our rotations. But I'm going to do a figure this time. This is your homework tonight.
What are we learning here?
We're not learning anything new. Do you want to do a 90 degree or a 270 degree?
260.
Okay. All right. On the coordinate plane. On the coordinate plane. before you can do any type of rotation, you first need the ordered pairs. That's negative 3, 1. What's the ordered pair for J?
Negative 3. Negative 4.
4. What's the ordered pair for K?
Negative 1.
6. What's the ordered pair for L?
2. 3.
3. And what's the ordered pair for M?
0.
All right, now, we are doing a 270-degree rotation. So, H prime, how do we do 270?
90 degrees. So
It's a positive 270, so we don't go to 90. It says opposite, no, you mean switch them, and we take the opposite of which one? The Y. So you go over 1, up 3, and that is going to be H prime. Label them.
What?
All right, now J prime.
You did that wrong. You did that wrong.
Over,
You did it from N, not H. Oh.
no, from the origin, we plot the ordered pair 1, 3.
0. My bad.
Okay? So now, J, to do 270, you flip them, you switch them, and you take the opposite of which one? The Y, the second one. So now I'm going to go over 1, 2, 3, 4, 1, 2, 3. This is J prime.
Oh, all you do is just switch them. You don't have to.
Switch them, and opposite of the second.
Oh, I see.
K prime, switch them. 6, negative 1, and now opposite of that one. 5, 6, 1. Now are you with me?
No, not at all. Switch them, isn't it just back to next 1, 6?
So now you switch them, 3, 2, and who goes opposite?
It's 3 negative.
Right.
Do they always switch?
For 270, they always switch. For 90, they always switch. It's the negative that's different. So we go over 3, down 2. Pardon? Once you switched them, you turn the second one opposite only. On 270. On 90, it's the first one that goes opposite. M, we need M prime. Switch the 0 and the 0 and take the opposite of 0. So that means that is M prime. So now you should be able to take your straight edge, and you should be able to go from M prime to H prime to J to K prime to L prime to M. Done. That is a rotation of 270 degrees about the origin.
Watch you just.
I tried to draw it.
Was it on the coordinate plane?
It was like,
A rectangle?
no, it was like an octagon with a triangle and a diamond and like 40 lines through it, and you had to like take the rotation of that.
Maybe you were just supposed to figure out which one it falls on.
Oh
Okay.
no. Rotate.
All right. I need a quiet. You need equipment.
Hey, Miss Bride, are you having tutoring at the school on Monday? Tuesday?
Tuesday I am available.
Alright, that'll be
All right. I don't know. I think this is number 10
For what?
on your homework.
Oh, I think I have.
And I think this is R, E, C, T. Now listen carefully. I'm going to get your equipment out. I'm going to take you through this again. You've got one of these on Wednesday. I'm rotating this rectangle about P, and I think they told me that it was a rotation of 90 degrees about P of rectangle RECT. So the first thing you will always do is you start at the center of rotation and you take a line through one of the points that needs to be rotated.
Oh, it's just last night's homework?
Yes. All right. So I need a compass.
Wait, it's coming out.
This is last night's homework. And I need a compass. All right, so here's my protractor. So let's talk about our positive and negative. Yes. No, you need to know this. All right. The center of your protractor always is on your rotation, center of rotation. Now, I think, did we want a negative 90 or a positive 90?
You said,
It says positive.
hold on, for 10?
Negative?
No.
11, 12 are negative.
Yeah, on the color.
All right, so we're supposed to do this in a positive direction. So the question is, if I start here and I go this way, am I going with the clock or against the clock? Against the clock is positive. So I need to go to 90. There's 90 right there. Against the clock means positive. Someone told me it was positive.
Yeah, 11 and 12 are negative.
So I'm going to move this out of the way. This sideways. And I'm going to take this through. I did it at 90. I made a dot at 90. Because I have to rotate C. What point are you rotating here? I'm rotating a vertex. All right. Now, you take your compass point will always, always, always be on the center of rotation.
Always.
Never anyplace else. Now you're gonna take your compass, and I need to get the same length. I need to extend this to point E. Do I have it?
Yeah.
And then I'm going to take my compass and I'm going to mark E over here. I can, and I don't know how that happened. So this is E prime. All right. So now I'm going to repeat this for C. But I want to make sure, and I think colored pencils would be beautiful. I'm going to go from P through C. Yes. So now I'm going to take my protractor and I'm going to move it. Where does this go? Never on C. It's always on. It's always about the center of rotation. Now my question is, it's not supposed to be on C. It's supposed to be on P. Okay. Is this against the clock or with the clock? Against is positive, so I'm doing well. I'm going to take my marker, and I'm going to mark 90 right there. Is 90. That is going, the hands of the clock do not travel this way. Yes. So, okay. If it's negative, I can't do it this way. I would have to rotate, and I would have to do this. Now, if I move this way, am I going with the clock? That would be negative.
And you mark it at 90 there.
And you mark it at 90 there. In the meantime, I'm going to go ahead and get my line. So now I'm going to go from here through that mark. So can you see that my blues match?
Yes.
So where do I put my compass point, Trevor Hush? On P. We're going to rotate it, and I need to measure what? C. So I'm going to shorten it there. I think that's about C. You see it? Now where do I take this? Up to my blue line and do what? That is what? This is C prime. So we're going to do this all over again.
So, Ms. Bright, what's our goal?
Our goal is to rotate this rectangle. Okay, so from P through T, I'm going to use green. All right, I'm going to put this on the center of rotation. Question. If I do this, is this going against the clock or with the clock? So that's wrong. So I need to move it this way. I need to go against the clock.
There you go. Why do you just always say that?
Against the clock is positive.
If it doesn't say that it's negative, then it's always against. Oh,
So now am I going against the clock? So here's 90. I make a mark at 90. I move this out of the way. I get my line. Well, I will move it over a little bit. So now I'm going to go from here through there. Now, back to where does the compass point go? On P. The compass point goes on P. Where does the pencil point go? On T. Now I'm going to rotate this to my green line, and what do I call this? This is T prime. Last but not least, what do I have to do? So I need a line again. This time we will make it purple. We'll make it a better purple. Isn't that a better? Here's it. Is that purple?
I don't know.
Well, we'll see. All right, so we'll try this again. We're going to do a light purple. All right, so here we go. We're going to go from here through R. We're going to get our protractor. Question. I'm going from here.
90 degrees. Right there.
Nope. I have to rotate it to my purple. Now, question. If I go from purple, am I going with the clock or against?
You're going negative.
That's with, so that's wrong. So I'm going to rotate it around here. Now, am I going against the clock? So where's 90? Right there. It won't let me write. All right. So now we're going to move this out of the way. And I'm going to get my line tool again. We're going to make it a purple again. So now I'm going to go from here to here. And where do I put my compass point? On P. And I measure R, which is just about there.
No, wrong line, Brian. No, that one's already there. There you go.
And this is R what? Now what are you supposed to do? You're supposed to I want to get a solid one. So now my rectangle rotated. I'm a little bit off. That's rotated. So you are going to be rotating a segment on Wednesday. All right? I gave first period another day on A31. Number 4? What did it say? Who has a worksheet or the CC that can read number 4 to me? What did 4 say? Wait a minute, I think Tara has it. What did 4 say, Tara? Shh, quiet. All right, again, my clock's fast. We still got time. Use the properties of rotations. You got to put them back.
I don't have a compass or
You have to buy one. I need them in here. Use the properties of rotations to describe how you know that the lengths of the diagonals of the square are equal. You know because SR fell on EQ by a rotation, that means we know rotations preserve what? Length. So that's why. Did you hear me, Maria? All right. If you finished A32 and you finished it well, you may turn it in. 31. Otherwise, I will take it on Wednesday. If you borrowed equipment, I need my equipment put back. Do today? You're welcome. Mm-hmm.